Welcome my students. Our today's discussion regarding refraction of light. We have already go through a phenomenon reflection of light. Now our phenomenon is refraction of light. What is refraction of light? Say a ray of light is traveling through a medium and takes entry on a second medium. This is the surface of separation of water and air. This is water and AB is the surface of separation of water and air. A ray of light traveling through air is incident on the surface of separation of water and air AB at the point O. Now, when the ray takes entry in the second medium, it will change its direction. The original direction of this, now it will go in this direction. At EQ, EO was the incident ray and OQ is the refracted ray. This phenomenon of change of direction of light in the second medium is called refraction of light. Now what is refraction of light? Traveling through a medium, say air, when a ray of light is incident on the surface of separation on a second medium having defined density and incident obliquely on the second medium, then the ray of light changes its direction in the second medium. This phenomenon is called refraction of light. Refraction means to deviate from original direction in the second medium. Now the incident ray has made an angle I with the normal and the refracted ray has made an angle R with the normal. Incident ray is EO and OR is the refracted ray. Sorry, OQ is the refracted ray. OR was the original ray. So EOM, angle EOM equal to angle of incidence I and angle UON is the angle of refraction R. Now there are some rules of refraction as well as there are also two laws of refraction of light. Now what are the rules of refraction? In reflection there is no rule. Reflection always occurs when a ray of light is obstructed by a second medium. That second medium may be transparent or may be translucent or may be opaque. But in case of refraction, the second medium must be transparent. The first medium must be transparent and second medium must be transparent. These media or mediums through which light can travel are also called optical medium. Now, traveling through an optical medium, if a ray of light be incident on the surface of a second optical medium, the second optical medium have different density on the first optical medium and the ray of light is incident obliquely, then it changes its direction, which is known as refraction of light. Now how will refraction be occurred from one medium to second medium? That depends on the density, optical density of the medium. Now depending upon the density of the medium, the direction of light changes. Now for the first instant, when rays of light travel from optically denser to rarer medium, In case of refraction of light from optically denser to rarer medium, say the denser medium is glass and rarer medium is air. Light is traveling from glass to air. Area of light EO is incident on the medium at point O. MON is a normal. Then the ray of light will away from the normal. This is the incident ray AO and OB is the refracted ray. So it is clear that when rays of light travels from optically denser medium like glass to optically rarer medium like air, then the refracted ray goes away from the normal. That is the angle of refraction R will be greater than the angle of refraction I. R is greater than I in this case. And when rays of light travels from optically rarer to denser medium, this is 2. Rarer to denser medium. This is air at denser medium water. Area of light is incident on the surface of water. Angle of incidence I. The ray will bend towards the normal. That is, angle of refraction R will be less than I. So when light refracts from rarer to a denser medium, then the refracted ray will go towards the normal, bend towards the normal. That is, refracted ray will be less, angle of refraction will be less than the angle of incidence. R will be less than I. These are the two rules of refraction of light, and depending upon the first rule, that is when light travels from optically rarer to denser medium, and second rule, first rule I have stated denser to rarer medium, second rule rarer to denser medium, and these are the two types of refraction of light. Now there are two laws of refraction of light. Two laws of refraction of light. The first law. First law, like the laws of reflection, I am not writing the law. Just like laws of reflection, the incident ray, the refracted ray, and the normal drawn at the point of incidence to the refracting surface lie on the same plane. Keep in your mind that you have to state about the normal. Normal drawn at the point of incidence through the reflecting surface. Through the refracting surface. Keep in your mind this statement regarding normal. So again I am stating the incident ray, the refracted ray, and the normal drawn at the point of incidence to the refracting surface lie on the same plane. This is the first law. And now the second law. The second law. This second law is also known as Snell's law. What about Snell's law? For a given pair of media, and given color of light, the ratio of the sine of angle of incidence to that of angle of refraction is always a constant. Sine I means angle of incidence, sine of I divided by sine R means angle of refraction, is always a constant mu. This law is also known as Snell's law. This mu is known as the refractive index. Mu is a constant, is known as refractive index of the first medium. Refractive index of the second medium with respect to the first medium. So according to Snell's law, for a given pair of media, say you are working with a pair of media, water and air. Light is traveling from air and entering in the water medium. This pair of media is a fixed pair of media, and you are working with a particular color of light. Say you are working with red colored light. Now if the angle of incidence be x, then sine x, and angle of incidence y, sine y, equal to, you will get a value. And if the angle of incidence be changed in those pair of media and of the particular color of light, angle of incidence becomes A and angle of refraction B, then sine A by sine B will have a value. That value will be similar to the value of first case. That is, if the value in the first case be mu, it will be in the second case. So what are the conditions for following the second law or Snell's law? Number one, particular or given pair of media and a given color of light or particular color. So if you are working by taking a pair of media, water and air, and I am working with a pair of media, air and glass, then sin I by sin r, first pair of media, will not be same to second pair of media. In that case, the constant mu will not be obtained. So this ratio, that is sin I is to sin r, will always be constant when light travels to a definite color for a definite pair of media and a definite color of light refracts in those pair of media. So these are the conditions for following Snell's law. Thank you, my students. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.